Half-life of radioactive isotopes. We talked already about nuclear decay, so either alpha or beta emission here on this other worksheet, and a half-life tells us how much time it takes for half of a sample of one of these radioactive elements to undergo a change to a different element. So in this case, we're looking at different problems where it gives us the half-life of a certain radioactive isotope, tells us how long that takes for half of the substance to decay into a different element, and then gives us an amount of it in this case, and it asks, so how much of this would remain after this amount of time? Now there are different ways that these questions can be asked, but I want to make sure you understand how to do all of them. There are examples in your reading material for nuclear half-life, and I'm going to go through the examples with you so you see how to do these. So number 1 says, how much of a 100-gram sample of gold-198 is left after 8.1 days if the half-life is 2.7 days? Well, I know I'm starting with 100 grams of gold-198. That's my given. Now, after a half-life, which I know is 8.1 days, or excuse me, which I know is 2.7 days, the half-life is 2.7 days. After 2.7 days, half of this substance will decay into a different element. So of the original 100 grams, only 50 grams of it will still be gold-198 after 2.7 days. So I draw an arrow and say that now only 50 grams are remaining, and that arrow, that amount of time that this took to happen, was 2.7 days. Now, I'm not at 8.1 days, which is what I'm looking for. I'm still at 2.7 days. So I'm going to do this again and go from 50 to 50 to 25 grams. Sorry, that looked like a decimal. So from 50 to 25 grams, another half of it decayed. It's not that after a half-life this became half, and then after another half-life this half was gone. Every time it is a random coin flip for each of the atoms in a sample of whether or not they will have undergone that decay. So it is always half of half of half, and so on. So after another half-life, I draw my arrow to represent the half-life. 25 grams is left, and I put a little mark here that it's another 2.7 days. Well, 2.7 days and 2.7 days gives me a total of 5.4 days total so far. I'm still not at the 8.1 days I need. So I go another half-life. 25, half of that becomes 12.5 grams, and that took 2.7 days again for that half-life to occur. And my 5.4 days I already had, plus another 2.7, gets me to my 8.1 days that I was looking for. So after 8.1 days, my 100 grams decayed into 12.5 grams. Another way that you can do this is if you know the total amount of time is 8.1 days and a half-life is 2.7 days, if you take 8.1 and divide it by 2.7, you're going to get 3. So you know that it takes 3 half-lives to get to your end result. And make sure that if you draw an arrow that you put an amount after it, because this arrow represents an amount of time that it took to go from this amount to the amount after the arrow. So number 2 says the half-life of potassium-42 is 12.4 hours. How much of the 750 gram sample is left after 62 hours? We're going to do the exact same thing again, where you can either write it out and do 12.4 hours each time, or go ahead and divide 62 by 12.4, and you'll get 1, 2, 3, 4, 5 half-lives, and you will go ahead and do it half each time for each half-life, and we get down to 23.4875 grams of the sample remaining after 62 hours. Number 3, though, now instead of asking how much of the substance we have left, now it's asking how many years have gone by. So in this case, the half-life of carbon-14 is 5,730 years, and if we start with 210 grams, how much will you have after 3 half-lives and how many years have gone by? So 3 half-lives, I do my arrow 3 times, 1, 2, 3, and I go from 210 to 105 to 52.5, and then all the way to my last one here, 26.25. and I know that this is how much I have left, and how many years did it take? Well, it was 3 half-lives. So 3 times this half-life would give me a total of 17,190 years. In number 4, we have to find the half-life. We don't know it. So we have a 50-gram sample of nitrogen-16 decaying to 12.5 grams in 14.4 seconds. So I'm going to take my 50 grams and decay it down to 12.5 grams. So I do 50, a half-life would get me down to 25, another half-life would get me down to 12.5, and that's where I'm trying to get. So it took me 2 half-lives. And because it took 2 half-lives in a total amount of time of 14.4 seconds, I know that these 2 amounts of time have to add up to 14.4. So I take that total amount divided by the 2 half-lives that I know it took me to get there, and I get a half-life of 7.2 seconds. Our last example gives us the half-life of a certain substance, of a certain radioactive element, and it asks if there are 25 grams of the sample left after 4.2 years, how many grams were in the original sample? So I'm going to go backward on this one. I start with my 25 grams that are left at the end of 4.2 years, and I'm going to go backward until I get to my original amount. So I started with 25 grams, go backward 1 half-life, which would be 1.4 years, go back another half-life, which after another 1.4 years would give me 2.8 total years, and then go one more time to get a total of 4.2 years. And every time, instead of dividing by 2, I'm going to multiply by 2 to get back to my original amount. So 25 became 50, became 100, became 200. So my original sample had 200 grams in order for it to decay down to 25 grams in 4.2 years with a 1.4 year half-life. So use these problems to help you set up questions 1 through 7 on this worksheet. So go ahead, write it out with the arrows so that you can tell how much you had and how much it's decaying into. And then if you do still have any questions on how to do these, please come ask.